All right, so anyway, just going over this, I've already been asked one of the last couple problems, and they're really interesting problems, these last couple. 26 was kind of interesting because we had a 30, 60, 90 and a 45, 45, 90. This is like what, you'll have a challenge problem like this on the test, probably, so just be prepared. But you probably will see a problem like this at some point. Try to rotate that around. I think it's like that, yes, okay. Oh, it's not big enough, so we will make it bigger. Oops, wrong way. A little bit. 26, I think. All right, there we go. All right, that's pretty close. All right. So we had a 30, 60, 90, and a 45, 45, 90. We were given that this is 7 right angles, 45, and x, and 60 degrees down here. Now, basically what you need to do when you get a situation like this is you break it up. This is a triangle I'll solve first, and I'll use that to solve this triangle. So essentially what we're going to do is we're going to pull this 30, 60, 90 down here. Say, okay, if this side is 7, how long is this side going to be right here? Okay, let's remember our 30, 60, 90 model. We got the short leg. This is a hypotenuse, so that's short leg times what? 2. Well, if 7 is a short leg times 2, then the short leg is 7 divided by 2, right? Or just 7 halves. We could leave it like that, right? But that's this leg right here, isn't it? That's the same as this piece right here. Oh, and since 45, 45, 90, that's 7 halves, and this would have to be 7 halves times the square root of 2. And if you did 3.5 times the square root of 2, I'd be fine with that. Yeah. On Wednesdays, we wear pink, but you shouldn't wear anything. Awkward.
What does it say? Name on it? Yeah.
To you from Lily. I think it's Mean Girls.
Oh, yeah, Mean Girls.
Okay.
Is there a Lily in this school?
I don't think so. But I don't have her in class, so it's probably just a joke somebody did. All right. Yeah, that's not at all awkward. Okay.
That's creepy. That's
all right, then.
Scary puppy creepy.
All right. So that's how that one gets solved. Any other particular ones you'd like to go over from the packet? Yes. Yes. Where? Because this is the 30, 60, 90 triangle, right? Or 45.
I don't know if it's wrong, but
I don't know either. But you can't, the thing is, the point of this whole problem is you can't go directly from the 7 to the x. I have to work through this shared side first.
Oh, I got 7 divided by root 2.
Oh, okay. Instead of 7 divided by 2. Okay. That's fine. All right. Other questions from the packet? If not, let's just review a few things. I'm just going to pick some problems. Say number 4. 4 root 28. These problems are going to show up again, and we are still having difficulty with these to simplifying things. Yes?
Are all the schools getting out at least, or is it just not?
Yeah, everyone will be getting out like an hour and a half early.
So, but I'm confused. They say we have to go to our 4th hour.
Yes.
But,
you'll go to your 4th hour for like 10 minutes, and then you'll be dismissed.
Not even because you go to 4th hour. Not even because 4th hour starts at 1:04.
Yeah, so you'll be there for like 5 minutes.
Okay, so what are we doing?
We have to have lunch for it to count as, that way we don't have to make up this day, probably.
Awesome.
Probably. Yeah, but we may have to make up the hours because we're really short on hours, too. So if we miss an hour and a half of school. You may have to make that up at some point.
What would you do to make them an hour after school? Come to school at 7:30, leave at 9?
They might, no, what they might do is just add a minute to each day or something like that, or 2 minutes each day. All right. It's what that has to be done. All right. So anyway, forward 28. Remember, when we are simplifying these things, I've got a lot of people who get it's all just multiplication. This just means 4 times the square root of 28. Now, we'll simplify the square root portion of it, and whatever that simplifies, we'll multiply that by 4. So 28 is not a perfect square. Half of 28 is 14, which is not a perfect square, but when we start with perfect square is less than 28, or less than 14. So 9 doesn't go into 28, but what does? 4. So root 28 is root 4 times root 7, but we still have this 4 on the outside. The root 4 is the perfect square one. That becomes a 2. It actually solves out. But notice I write this 4 every time. A lot of people make mistakes here because they just get lazy. And they don't keep writing the 4 times. The only time we stop writing 4 times is when we actually multiply the 4 times 2 because they're both on the outside. And there we go. So again, don't be lazy here when you're simplifying these square roots and not want to write out your steps because it just doesn't pay off. You make way too many mistakes. Go ahead and write out your steps. You will do better. Yes?
Can you go for number 7?
I can absolutely do number 7. 3 root 8 times 4 root 6. Okay. All right, so all we have to do, I'm just thinking, for some reason I was just noticing that it's almost like it's turned back to blue, but I guess it's still purple. All right, so we multiply, remember it's all multiplication, so so this is really like 3 times 4 times root 8 times root 6. The 3 times 4 is 12 root 48. Okay? Now, we do need to simplify root 48. So again, we start looking. 48 is not a perfect square. 49 is, but 48 is not. So half of 48 is 24. That's not a perfect square. But so we'll start looking at perfect squares less than 24. First one would be 16. Does 16 go evenly into 48? It does. 3 times. Okay, splits up. Root 16 solves out. That's just 4. And now we multiply those 2 on the outside. And the fact that we wind up with a 48 on the outside here really has nothing to do with the fact we had a 48 up here. It's just coincidence. So again, we put it together and we simplify it. Now things like number 5, root 4 over root 3. How do we rationalize this again? Yeah, we multiply it by root 3 over root 3, the denominator. I'd simplify it if I could. I can't. So we multiply by the denominator through, so that gives me root 12 over what? Root 9, which is 3. Now, I can't reduce the 12 and 3, but I can reduce root 12. Root 12 is root 4 times root 3 over 3. That's 2, so 2 root 3 over 3. That one required a little extra simplification. Okay. It's a present for you, I guess. So anyway, that's how something like that goes. The other thing we run into are things like, say, number 10, Pythagorean theorem. And when we get to the test here, a lot of people have a tendency to just want to run the trig for everything. Remember, we don't have to run the trig all the time. In fact, if it says, give your answer in simplest radical form or something like that, odds are we aren't using trig at all. So make sure you're looking when you're taking this test of the instructions. It says leave your answer in simplest radical form, 3 and 2 root 3. And this is x. All this is Pythagorean theorem. X squared plus 3 squared equals 2 root 3 squared. Now, x squared plus 3 squared, that's easy. That's x squared plus 9. This is the part that trips people up. What is 2 root 3 squared? Well, when we square something, 2 squared is, root 3 squared is 3. So x squared plus 9 is 12. So x squared is 3. So x is the square root of 3, which does not simplify. And there we found our third side. So we can solve that pretty easily. But again, we have to be able to square something. So just as a very quick review, whenever I have a root b squared, okay, any two numbers like that, we distribute the squared, so that's a squared times root b squared, or a squared, because root b squared is just b times b. That's the way it always works for any two numbers. Yeah.
So you're saying if the square just cancels the radical?
Squared cancels the square root. Yes, they're opposite functions. Whenever I have anything squared, I could have x squared plus 3x minus 2. Okay. Something in a radical like that. Big polynomial, square root. If I square that, the squared and the square root just cancel. Squared and square roots are inverse functions. They cancel each other out. Inverse functions. We've already kind of done 30, 60, 90, 45, 45, 90 thing. Acute right obtuse. Let's look at number 12 real quick. We had root 22, root 119, and 12. And this is the angle we're checking as acute right or obtuse. So, when I set this up, remember, don't put an equal sign in there because we don't know if they're equal or not. We can just leave a blank. What's root 22 squared? We just said square root and squared cancel each other out. It's just 22. Root 119 squared is going to be 119. 12 squared is 144. This is going to give me 121, 141. Oh, goodness. The one that's by itself is too big. This being the Goldilocks chapter, too big, too small, just right. Too big means the angle's too big, which means it's obtuse. Okay, that angle is obtuse.
Why do you go for that?
Because that's the largest angle. We always classify a triangle according to its largest angle. So we always go with the largest one. And I know it's the largest angle because this is the longest side. Now, in order to actually find that angle, because it's not a right triangle, we would need actually more advanced trig than what we do. We need something called law of cosines. But that's basically Pythagorean theorem with a special factor put in to account for the fact that a triangle is not a right triangle. So, nothing you need to worry about. But it works. Let's look at the triangles here, say 14. Always love these problems. And again, kind of the Goldilocks chapter here, we get the three different triangles. Where am I at here? Oh, I should have flipped it, I guess. If I need to rotate it, just flip it. There we go. All right, so we had the altitude in here. This is 60. This is 25. X is down here, and right angle's there. And I mean, on the test, actually, when I ran off the test, I literally drew on the test our 3 triangles for you for the first one, just to make sure that you remember what's going on here. All right? I mean, I literally drew those triangles on and made them, you know, mama bear, papa bear, mama bear, baby bear things. All right? So we've got our 3 triangles.
Why don't you just make that one bigger because they're going to be harder to small.
It's done. Okay? So we start with our outer triangle. I don't know, start with the short leg of the outer triangle. It's here. I don't know it. Long leg, I don't know. Hypotenuse, I do know, would be x plus 25. Probably not going to have to work with that, but okay. Next, we go to the mama bear triangle, which is the middle one. Start with the short leg. That short leg is 60. Yes, 60. The long leg is x. Hypotenuse, I don't know. Finally, we go to the baby bear triangle. Start with the short leg. That's 25. The long leg is 60. And I don't know the hypotenuse. But I've got enough to set up my proportion now, don't I? So if you really take the time to just draw those 3 triangles, it's not that hard. I mean, short, medium, long, short, medium, long. We can handle that one. Like we said, that's like a Sesame Street concept. Which is the biggest? Which is the littlest? Which is the middle? I know you can handle that. If you just take the time. So, setting up our proportion now, x over 60, 60 over 25. When I cross multiply, I get 25x equals 3,600. Now, I don't take any square roots here. There's no x squared. We'd had this on the last test, a problem like this, and people just were doing all sorts of things with square. They get this far, and then they take the square root. It's not 25x squared. It's just 25x. This is a basic Algebra 1 linear equation. No square roots necessary. I just divide by 25. And so that x is going to be 36 times 4, which would be 120, 144. Okay? And we're done. They aren't that hard when you just break them into little pieces. But you have to take the time to identify short, middle, long, and write that in. And short, middle, long, write that in. And short, middle, long, write that in. Then if you do that carefully, the proportion when you see the picture with the 3 triangles is usually very obvious. So just be patient with it. Really, a lot of this stuff comes down to just being a little more patient. 30, 60, 90, 45, 45, 90, we've kind of done that. Let's just look at a little bit of trig. What time is this? This is 58. 4 minutes. Good, we got time for a couple trig problems.
Can we do one long trig problem?
Let's do a...
Is there going to be a story problem on our...
There could be. So let's just do 22 quickly. Okay. In 22, I had a 40, a 19, and I want to know this angle right here. So remember, when we're doing this, this is where we use the table. If this is my angle, this side is the opposite. 40 is the hypotenuse. Which function uses that? Sine. So sine of my angle is 19 over 40, which if I decimalize that, gives me 0.475. And all I have to do once I have that decimal is go to that chart in the back of the book, or I'll have those sheets again, page 925. You can use your calculator if you're good at that. But let's try to keep it, I like the chart just because then the calculator and knowing how to use your calculator doesn't enter into it. You can just look at the chart. If I go down my sine column and I find 0.475, which would be between 28 and 29 degrees. In fact, almost right in the middle for sine. Probably a little closer to 28.475. So I'd probably call that 28 degrees. Okay? So that angle is about 28 degrees. Yeah.
So can you use our calculator and like put sine -1 the equation?
You could. Yeah. But again, don't overcomplicate things. It is pretty straightforward. All right, that pretty much covers what we have for time. The book assignment is still out there. I would work on that tonight. Tomorrow we'll do another review. And so test is now on Wednesday. For those who, if you have friends who are not in this hour, I will let 4th hour know this podcast exists in the notes. But if you have people who are in 8th hour, just let them know that this is out there as an extra review. Yes.
So we're not going to 8th hour?
No.
You're going to lunch. 6 hour.
I said lunch.
Oops.
The third one, then it goes 6, lunch, 4 hours.
I'm very confused.
You just continue on with your day.
Okay, I go to 6 hours, then go to lunch.
Then you go to your 4th hour class after like we normally would on a late start day. It's just that you'll only be there for a few minutes. So
Do I go to 7th hour now?
no 7th or 8th hour today. You have to do it home.
Yeah, he's like, you need to jump rope.
$4.98.
Wall jump.
Just sit on.
Height flies.
Sit down, please.
Dribble